And we're right at 2 o'clock, so I think we'll get going. Thanks to everybody for joining us today. Looks like it's a good day to be inside hiding from the snow. We are recording this presentation today, so that'll be available for a resource in the future if you want to check back or share it with anyone. We are in the webinar format, so right now we can't see or hear any of the participants. Feel free to use the chat, but also if you do want to speak, it looks like I do have the ability to allow any of you to talk. So once we get to the question period, we can for sure unmute you guys if you want to get more of a discussion going there. That's no problem. Yeah, so Caitlin and I decided to plan this webinar. Caitlin is our soil specialist at Perennia. She's very keen, and when we were on a farm visit last year, she started talking about the cation exchange capacity, and she has a really good way of explaining it. So I asked if she'd be willing to give us a presentation on soil reports this winter. So here we are now, and I'm going to turn it over to her.
Thanks, Michelle. Hi, everyone. As Michelle said, I am Caitlin. So I'm just going to be talking about what else your soil test report might be telling you. That might be some important information that you need to help choose some management practices. So before we get going, I'll just introduce myself. We're going to go over. Introduce myself a little bit more. So I'm a soil specialist at Perennia. I started last July. So I did my undergrad at the Dal Agriculture campus, and I'm currently finishing up my master's with a focus in responsive soil chemistry to liming. So my role at Perennia is to help producers with any soil related issues and help provide information about soil and extension. And so if you have any other questions or anything else you're wondering about at the end of the presentation, I'll definitely make my contact information available for you guys to ask any questions that we might not get to in the presentation today. So for the presentation today, what I'm hoping that you guys can get out of it is any additional information you need on interpreting your soil test reports. So I'm going to briefly go through all of the elements of the soil test report, but I'm going to specifically focus on cation exchange capacity and base saturation, because those are the two elements of the soil test report that often get overlooked. And then I'm going to give you some considerations for your management practices based on those two concepts. But before we go any further, I just want to talk about taking a soil sample. So in order to have a soil test report and to have a soil test report that you can use and that will be valuable for you, you need to make sure that you're taking a good soil sample. So you want to make sure that the soil sample is as representative of the area as you can. And you want to target about 15 to 20 soil pores, depending on the size of your area. And you want to target about 6 to 10 inches deep, or about 15 to 20 centimeters. And this may change a little bit depending on the rooting depth. So particularly for tree fruit crops, if your rooting depth is a little deeper, you may want to consider going a little bit deeper or taking separate soil samples. So the other thing that you want to consider while taking a soil sample is to take different samples in different parts of your field if they vary. So if you see a significant difference in the soil texture, the topography, or the drainage class, you may either want to take a different soil sample, or if it's just small pockets, you may want to avoid those areas and make note of them for your management practices. So once you take a subsample of all these different spots in your orchard or in your field, you want to mix them well in a bucket, and then you'd put them in a little soil box or bag and labeled, and send them to the Nova Scotia Department of Agriculture Analytical Lab. One of the other considerations that's really important is to always sample at the same time of year. So in general, we recommend about once every 3 years. That may need to change depending on if you're seeing some changes in your soil or if you're noticing a reduction in yield that might be as a result of a soil related issue. You may need to take additional samples. But the results of a soil test, particularly pH and organic matter and some of your nutrients, may fluctuate throughout the season. And so taking a sample in September and then taking a sample 3 years later in July, you're likely going to see very different results, but you won't be able to tell whether that's an effect of your management practices and time, or if it's an effect of the seasonal variability. So taking a soil sample will help guide you on your nutrient decisions and allows you to keep track of your soil nutrients over time. So the things that we're going to be looking at on the soil test reports are your pH, your organic matter, your macronutrients, your micronutrients, cation exchange capacity, and base saturation. So I'll go through each one of these, describe what they are and what they may mean for management practices. And then we can talk about any additional information or questions that you may have at the end. So the first thing my eye goes to every time I look at a soil test report is pH. So there's two different pH measurements on your soil test report. And you want to make sure that the most important one that you're reading is the top one. So that's the measure of the active hydrogen ions in your soil solution. So it's a measure of your soil's acidity. So that's going to be a large indicator in whether or not you need to lime. And then the second pH measurement is your buffer pH. So that's the residual acidity neutralized by lime. So this is mainly used by the lab to get your lime recommendations. And so you don't need to worry about this number as much, but this number is the important one. So this will give you your lime recommendations, this buffer pH, and this is your lime recommendations is the amount of lime required to increase your pH to 6.5. Now these may be different depending on your crop. So your recommendations may change. So for instance, if it's a different crop, you may not want your pH to be raised to 6.5. So your lime recommendations will change. So pH is on an inverse logarithmic scale. So what this means is that for every 1 unit increase in pH, there's a 10-fold decrease in hydrogen ion activity in your soil solution. So a pH increase from 5 to 6 is a lot different. It's a lot greater than it seems. So specifically for tree fruit crops and apples, you want your pH to be within that 6 to 7 range. So in Nova Scotia, our soils tend to be acidic through natural and anthropogenic causes. So we just have naturally underlying acidic bedrock. And then things like plant uptake and podilization, which is the movement of nutrients downwards through the soil profile, can increase that soil acidity. And on top of that, things like fertilizers can further increase that soil acidity. So that's kind of the number one thing you're going to look at. And if your pH is below the range that is adequate for proper plant growth, this is going to affect your nutrient availability. And nutrient availability is going to be a common theme that I'll talk about a bit today. But essentially things like nitrogen, phosphorus, potassium, calcium, magnesium become more available at greater pHs. So if you do have a low pH on your soil test report, one of the main things that you can do to mitigate that is apply lime. I'm not going to talk about liming too much because that can be a whole topic in itself. But basically, you want to apply calcium amendments or amendments that have an acid neutralizing capacity. And so the choice of liming material is often based on transportation costs. However, it can also be based on your soil test report. So in general, if you have a low pH, here it's also going to be associated with a low calcium level. However, this isn't always the case. What you also want to look at is your magnesium level. So if you have a low calcium and magnesium level, you may want to consider dolomite. If your magnesium level is within an adequate range, then you may want to consider calcite or other options that may be more available. Another example is gypsum doesn't necessarily change the pH, however, it does increase your calcium concentration. So that's another reason why you want to have a look at your soil test report. Even if you need liming, it may help you decide what type of liming materials you want to use. The second thing that you look at in your soil test report is your organic matter percentage. And so I often refer to the organic matter as the bank. So this is where you're going to store a lot of those plant essential nutrients. And this is often an indicator of soil health. And so what organic matter can do is it provides nutrients, it adds structure, it increases water holding capacity, it reduces your risk of erosion, increases biodiversity, and it increases your cation exchange capacity, which I'll talk about a little bit more. So these are all the things that goes into your organic matter. So organic matter is the combination of living and dead plant and animal matter in the soil. So there are all kinds of different things. So your roots go into your organic matter percentage, your macrofauna, microfauna, and these are all living or dead. And so for, you want your organic matter range for apples, probably within the 2 to 4%, a little over, a little under, you can definitely work with. However, you want to keep in mind that in some other crops, having this percentage a lot higher is beneficial. So you want to make sure that when you're looking at your organic matter, you're looking at it specific to your crop. So the next thing you're going to look at on your soil test report are your different elements and different nutrients. So these are the essential elements for plant growth. And so we have them color coded here. So you have your basic building blocks, which is your carbon, hydrogen, and oxygen in green. And then your macronutrients, phosphorus, potassium, and nitrogen. And then the next three most important would be sulfur, calcium, and magnesium, which would be kind of your secondary nutrients, and then your micronutrients in orange, which are also very important. And you want to make sure that when you're looking at your essential nutrients on your soil test report, that you're looking at them either from a perspective of looking at them in excess or if there's not enough. So a lot of times we're worried about whether there's enough, but not necessarily looking at if there's an excess, which can occur as well. And so this just kind of shows, this is the different essential elements and where they come from. So these are often sourced from fertilizers, and these can be sourced from air, water, and soil, although nitrogen can also come from your fertilizers. So specifically for apple production, you can kind of rank some of these plant essential nutrients in order of importance. So you want to make sure that you're looking at your potassium and your nitrogen first, your calcium and magnesium, and then your phosphorus. And I'll touch on each of these nutrients in a little bit more detail. So the first one that you can look at is nitrogen. So low nitrogen can lead to low vigor, poor shoot growth, discolored leaves, and potentially smaller apples. But the main thing that you have to realize with nitrogen on your soil test report is the basic soil test report that most producers use doesn't actually measure nitrogen. But it has a nitrogen recommendation, which is mainly based on the crop that you put in. So it's really important when you're submitting your soil sample to make sure you write down what crop you're using, because if you don't, they aren't able to give you nutrient recommendations. So the availability of nitrogen in soil is biological. And what that means is that it's driven by the microbes in the soil. So different processes involving the biology of the soil have to occur in order for nitrogen to be available for the plant. So for example, approximately 20 to 45 kilograms of nitrogen per hectare per year is available with each 1% of soil organic matter. So the next one that we'll look at is phosphorus. So the big thing with phosphorus is the availability. And sometimes I like to kind of refer to phosphorus as like the cool kid, because they're never available, and you also have to allow phosphorus. You have to go to phosphorus. It won't come to you if you're a root. And so what I mean by that is it's really dependent on the soil pH. So if you look here at lower pHs, phosphorus is also often taken up or fixated by aluminum and iron. And then at higher pH, fixation with calcium can occur. So there's kind of this middle ground, this between 6 and 7 pH, where phosphorus becomes more available. And so phosphorus doesn't migrate to roots. And so the roots have to go to where phosphorus is in order to take it up. So there is a possibility of having higher content of phosphorus in your soil, but it not necessarily being plant available. So phosphorus is represented by P2O5 on your soil test report. And so if you're looking at just phosphorus, you need to make sure that you use the conversion to get it to just the phosphorus amount. However, it's represented like this, and similar for potassium, it's represented as K2O, because that's what's used for fertilizers. So it's easier to make that connection. So specifically for apples and for tree fruit crops, younger trees require higher amounts of phosphorus, but the requirement decreases as the trees age. So on your soil test report, your soil phosphorus recommendation for fertilizer for your nutrient requirements is down here, and the total amount is listed here. Similar to potassium, as I said, you have to make the conversion, but potassium is a little bit more readily available in soil. It moves with water, and it can move to the roots. However, that means that potassium is mobile, and it can be subject to leaching. So organic matter is not necessarily a major source of potassium, but high organic matter increases the cation exchange capacity, which helps soil retain potassium. So I'm going to talk a little bit more in detail about potassium later on in the presentation and what that means. The next thing you'll look at is your calcium and magnesium. So calcium and magnesium, particularly calcium, can help with cell nutrition. It helps with stress response. It improves the absorption of other nutrients. And then magnesium can help move phosphorus, so it can help make phosphorus more available, and it's important for photosynthesis. So now if your calcium and magnesium levels are low, you can apply lime to help mitigate that. So on your soil test report, you'll see that you have these ratings for these 4 nutrients. And so these ratings are associated with these values in black. So these are the values used by the Nova Scotia Department of Agriculture Analytical Lab to determine whether your nutrient concentrations are low, medium, or high, or excessive. And so the numbers I have here in red are a different resource. And so that's something you want to pay attention to when you're looking at the numbers, is that not all resources will give you the exact same values for what they consider a high concentration or a medium concentration or a low concentration of these nutrients. So specifically for these different recommendations, so these are the recommendations for all tree fruit crops in black for Nova Scotia. You can see the red values are quite different, particularly for calcium and magnesium. And so that's something you may want to be aware of, that even if it's saying it's medium by the standards at this lab, perhaps for your particular species or your particular crop, you may need to look into it a little bit more to see if that's actually an adequate range. So the next thing on your soil test report will be your micronutrients. And I won't go into too much detail about each individual micronutrient. However, a lot of them are available in Nova Scotia soils, or Nova Scotia soils have quite a few. So particularly for iron, manganese, aluminum, some of these nutrients, as pH decreases, they become more available, opposite to calcium and magnesium. And so some of these nutrients are not necessarily readily available, even if they are in high concentration in the soil. So what a lot of producers may do is take tissue analysis as well to see if the nutrients that are in the soil are actually being taken up by the plant. So for instance, zinc here in this soil test report is really high on this fourth value here, but that doesn't necessarily mean that the plant is taking up that available zinc all the time. So now I am going to talk about the cation exchange capacity. So as I said before, this value I think sometimes gets overlooked because you're not really sure what to do with that value. Even if we understand the concept, what does that mean for management practices? So cation exchange capacity, by definition, is the total amount of exchangeable cations that a soil can absorb. So some key points to keep in mind is it's the ability of the soil to retain important nutrients. It contributes to the buffering capacity of the soil, or the ability of the soil to resist changes in pH. It's dependent on the number of negative exchange sites found on soil organic matter and clay particles. And it can be difficult to alter. There are definitely ways that you can change your cation exchange capacity. However, there are some management practices that you can do that will more so compensate for your for a low or a high cation exchange capacity versus actually manipulating the value. So before I go any further, I want to talk about texture. So cation exchange capacity is really dependent on texture. So you can see this list of different textures here. You have your sand has a low cation exchange capacity. So what it's the unit they use is milliequivalents per 100 grams. So it's a concentration of cation exchange capacity. As you go down, in clays have a much higher cation exchange capacity, and in organic matter it can be very, very high. This is because clay and soil organic matter have these negatively charged particles. So often you'll see the word soil colloids, and this refers to your clay and soil organic matter. And these are the most chemically active portion of the soil. And so when you're looking at your soil texture, the more clay you have and the more soil organic matter you have, likely the higher cation exchange capacity you will have. And just to give you a reference point of the size of these different particles, the tip of a pin is approximately 1.5 millimeters. And so clay particles are a lot smaller than that. And so even though they have a smaller particle size, they actually have a larger surface area and a larger area for nutrients to bind to. So cation exchange, well, let's break it down. So as I mentioned, cation exchange is as a result of the negatively charged surfaces on clay and soil organic matter. So it'll depend on the amount of clay in your soil, the type of clay in your soil. Different types of clay have different amounts of negative charges, and the amount of organic matter in your soil. So what's actually happening? So first we'll look at the players. So when we're looking at cation exchange, we have to look at the cations. So cations are positively charged ions or nutrients in your soil. So the main ones that we look at in cation exchange are your basic cations. So these are cations that are basic on the pH scale. So they're not going to decrease your pH. So calcium, magnesium, sodium, and potassium. And then your acidic cations, hydrogen and aluminum. Now, particularly for our soil test reports, we don't look at aluminum as closely, but you may find if you read anything further on cation exchange, they also take aluminum into account. So cation exchange occurs on these soil colloids, so your clay particles and your organic matter, and so they have a negatively charged surface. So this is all sometimes called the cation exchange complex. And so it also occurs in soil solution and then on negatively charged root hairs. So these are the three areas that you're looking at. So first, what happens if you have positively charged ions attracted to these negatively charged surfaces? So as we know, opposites attract. And so what happens is that you can have these ions exchanged for other cations that are available in soil solution. So these nutrients in soil solution become plant available. So for example, if you have two positively charged potassium ions, that can exchange with one positively charged calcium ion because the charge is different. So once these nutrients are in plant solution, they can be available for plant uptake. So I'll show you a couple diagrams that explain this a little further and in a couple different ways. So this first one, you have your soil particle, you have your positively charged ions that are exchanged in soil solution. And then your root hairs, which produce hydrogen ions, can then exchange these hydrogen ions with calcium, and then it can be taken up by the plant. One thing that's important to note when you're making this exchange is that the exchange with hydrogen ions will actually decrease your pH. So natural plant uptake does have an acidifying effect. This is another example. So you have all these different positively charged ions, and the ones in red are your acidic ions, acidic cations, and the ones in green are your basic cations. And these can be released into soil solution and then made available for root uptake. Again, this is kind of the same thing, just a different figure. So just to give you a little context, a soil with a cation exchange capacity of 1 has that many, I'm not going to try and say that value, but it has that many adsorption or exchange sites in 100 grams. So about a quarter pound of soil. And the range for agriculture soil is approximately from below 5 to 20. And this again depends on the texture. So another important thing to notice when you're seeing this exchange is different ions hold on to the cation exchange complex more tightly than others. So I won't go through this whole comic, but basically the idea of the comic is that these different nutrients will hold on to these negative charges tighter, and then they'll be replaced by the other nutrients coming in, and the tighter they hold on, the more energy they may require to be replaced by other nutrients. So I'll give a couple analogies. So one of the main analogies I see a lot with cation exchange is thinking about it in terms of cars in a parking garage. So if your parking spots are your negatively charged particles and your cars are your different cations, and your parking garage is full, then you would have to exchange these different cars to get the new cars in. And you can even think of like the different colors as different cations. But basically, as nutrients are moving in and out, so would cars in a parking garage. The second way you can think about it is thinking about a balloon. So the reason why cation exchange can occur is because these nutrients aren't held extremely tightly on the cation exchange complex. So they're held by these electrostatic forces, which is similar to when you rub your hair with a balloon and stick it on the wall. So why is cation exchange capacity important? So cation exchange capacity can have different meanings, and it can have different meanings for and change your management practices. So it can mean different things for nutrient management. It can alter your fertilizer use efficiency, the way you lime, and also your drainage. So I want to talk a little bit about fertilizer efficiency. And so what happens is that if you know your cation exchange capacity, can get a general sense of how much nutrients your soil can retain. And so this may alter the amount and timing of your fertilization. So for example, if you look at this top picture here, so this is actually a video, you have two different sized cups. So if the larger cup represents the soil that has a high cation exchange capacity, where the smaller cup represents the soil that has a low cation exchange capacity. And what I'm going to do is pour the exact same amount of water, 1 cup of water, into each. So this water may represent your fertilization. And so what happens is the soil with the larger cation exchange capacity is able to retain those nutrients that are applied by the fertilizer. However, the soil with the lower cation exchange capacity, you see that there's an overflow. And what happens is when there's not enough sites to bind these available nutrients, these nutrients are lost and can be leached through by the system. So a way that you can look at it, instead of allowing this to overflow and applying the same amount every time, if you think of this syringe that's as plant uptake, so as a root, and it's taking up these nutrients supplied by the fertilizer, and then you can replenish it afterwards. So having a lower cation exchange capacity doesn't necessarily mean that your soils are less productive. It may just mean that you may have to use smaller amounts of fertilizer at more doses throughout the season. So this similar concept applies to lime and buffering capacity. So as I had kind of mentioned before, the buffering capacity is the ability of the soil to resist changes in pH. So sandier soils with lower cation exchange capacity will acidify more readily. However, they'll also recover more readily. So they are able to kind of lose and regain their nutrients, and they have a lower buffering capacity. Whereas soils with higher clay don't have as large as a buffering capacity, and more lime is required to make changes. However, they don't acidify as quickly. And so this ties back into the lime recommendation that the lab gives. So this is what your buffer capacity, your buffer pH is in reference to. So next is your texture and drainage. So in addition to cation exchange capacity giving you an indication of how many nutrients your soil can hold, it can also give you an indication of your water holding capacity. So soils with a higher cation exchange capacity tend to have a greater clay content and or soil organic matter, which increases your cation exchange capacity, but can increases your water holding capacity, but can also have implications for drainage. So you need to be aware that if you have a really high cation exchange capacity, this may mean that you have more clay in your soils, which may impact your drainage. So you may have less rapidly drained soil than soils with a lower cation exchange capacity. So after talking about cation exchange capacity, the next thing on your soil test report is your base saturation. But before I get into too many details about base saturation, I just want to touch on this balance versus amount of nutrients in your soil. And so on the soil test report, when we talked earlier about particularly phosphorus, potassium, calcium, and magnesium, we saw that there were those sufficiency thresholds for low, medium, high amounts of these nutrients for a certain crop. But what that doesn't take into account always is the interactions between nutrients. And the balance of nutrients in your soil is very important. And this is where base saturation plays a large role. So base saturation on your soil test report looks like this. So you have 5 different base saturations. So these are the same nutrients that are involved in cation exchange. And so base saturation is the ratio of calcium, magnesium, potassium, sodium, and hydrogen on the cation exchange complex. It's closely related to pH, And this is because it gives you a base saturation of your hydrogen ions, which is directly related to your pH. And so you would prefer to have your base saturation dominated by your base cations, particularly calcium. And so these are measured relative to each other. So what this means is that if you have an increase in your calcium base saturation, this has to be compensated somewhere by a decrease somewhere else. And it may be a decrease in several different nutrients, but it's always, these measurement is always relative to each other, and it should always equal 100%. So the difference between cation exchange capacity and base saturation. So base saturation, again, is the amount of each of these nutrients relative to each other on the cation exchange complex. So I apologize, these graphics are a little bit blurry, but the difference between low and high cation exchange capacity is in reference to the amount of different exchange sites that are available. So you see that this low cation exchange capacity only has 4 negatively charged charges, whereas the high cation exchange capacity has much more. So if you look at a soil that has the same cation exchange capacity, but it has a different base saturation, so it has a different saturation of calcium on the cation exchange complex. So you see by the greater amount of blue cations as opposed to red cations. So in general, on your soil test report, on your base saturation, you'd like to see 65 to 80% calcium, 12 to 18% magnesium, less than 1% sodium, 2 to 10% hydrogen, and 4 to 8% potassium. Now, you may see different numbers represented elsewhere. And so, for instance, for magnesium, so I've seen some that say as low as 5% is okay. And this is also largely dependent on the crop. So this is a general for crops, for all crops. It's not specific to apple production or any crop. Particularly for hydrogen, 2 to 10%, that is going to be dependent on your pH. So if you have a base saturation for hydrogen of 0, that means that your pH will be 7, so it's neutral. And so if you have sodium, which is greater than 1%, this is likely a result of a drainage issue. And in lighter soils versus heavier soils, so clay dominant versus sand dominant soils, you may need less or more of some of these nutrients. So that's another thing that you want to pay attention to. But in general, when we're looking at this soil test report here, you can see that there's really only one sample here that has adequate calcium, and even that's a little bit high. But as you see, this calcium is quite low, but that's because it's compensated for by an abundant increase in hydrogen ions. And this is reflected in the difference in pH, where this pH is quite a bit lower than these pHs. So yeah, depends on texture. So this is another way just to represent it here. So the reason why the base saturation depends on texture is if you have a high cation exchange capacity soil, so a clay dominant soil versus a sand dominated soil, but say that each one of these circles represents 100 parts per million. You can have the same amount of potassium, say, on a high cation exchange capacity soil versus a low cation exchange capacity soil. But in one, the base saturation may be higher. So what I mean by that is you still have 300 parts per million of potassium on each one of these soils. But in this case, potassium isn't being outcompeted by magnesium and calcium for plant availability on the cation exchange complex. So you can see there's a lot more calcium and magnesium here, which may outcompete potassium. So this means that even though it's the same amount, the balance is different. So for example, this is from a soil test report, and you can see that there's a big difference in the amount of K2O in the soil test report, almost double or more than double, but the cation exchange capacity is quite different. So even though there's a much greater amount of potassium in this soil on the right-hand side, the percentage of calcium on the cation exchange complex is lower because the cation exchange capacity is higher. So for some management considerations when looking at base saturation, you need to look at nutrient ratios sometimes. Now, sometimes these nutrient ratios aren't as readily available, and they're often more available for plant tissue samples than soil. But what's important to remember is that calcium and magnesium compete with potassium. So if you add an abundant amount of magnesium and calcium by liming per se, you may notice a decrease in your potassium availability. So that one thing you may want to look at, and this can be done by nutrient ratios as well, is looking at your limiting nutrient. Because if your limiting nutrient is potassium, say, but you keep adding a lot of nitrogen, but your soils have a low cation exchange capacity, you're not going to be able to retain that nitrogen, and it's going to be lost, and that's going to may cause damage to adjacent environments, and you're also going to be losing money because you're not getting the most out of your fertilizer application. So before I finish, I just want to give just a little brief overview on soil texture and some ways you can determine your texture, because I've talked about texture a lot in this presentation because it's because cation exchange capacity heavily depends on texture. So we have this soil texture triangle. So it's the relative abundance of sand, silt, and clay in your soil. And so there's two easy ways to quickly determine texture. And really, you're not going to get an exact percentage doing this, but you may be able to tell whether it's more sand or more clay dominant. And that's by just taking a bit of soil in your hand and making it wet and rubbing it between your thumb and forefinger. The three things that you're going to be looking for is a grittiness for sand, a greasiness, almost as if it stains your fingers for silt, and then a stickiness for clay. Or you can do what's called the ribbon test, where if you run the soil through your thumb and forefinger and it sticks together and forms a ribbon, then that means that there's likely a high amount of clay. Otherwise, you can use what's called the jar test or the shake jar test, and you put a bit of dried soil in a mason jar. You add water to about 2/3 the amount of soil, and then you want to also add a powdered laundry detergent, which helps coat each individual soil particle, and shake it for about 3 to 5 minutes and let it sit for about a day. And that way you can see the different textures. So you can see that you have a higher abundance of sand here, silt, and then your clay up at the top. And I just have a little toolbox icon here because that's a fun tool that producers can use. They can do it in their home or do it in their fields. So just an overview, we talked about the importance of soil sampling and how to take a soil sample, and then all of the different parts of the soil test report. So pH, macro, micronutrients, and then we dove a little deeper into cation exchange capacity, base saturation, and potential nutrient ratios, and what those mean for our management practices. So if you have any questions, please ask, and I will answer them to the best of my ability. Thank you.
Thank you, Caitlin. That was great. I don't see any questions coming in on the webinar platform, but I did get a question through text here, and we were chatting a little bit. So the question is with regards to the nutrient levels that are reported by the provincial lab. Okay. That table with the black values and then the red values as well. So do you know any more, or can you remind me if those recommendations given by the lab, like the low, medium, and high, are those based specifically on apple, or is it for a range of perennial crops?
So I'm not 100% sure if it's specific to apple, but they're specific to tree fruit is the list that it gives. So that information is actually available readily online. If you just go, I can provide the link, or if you go on and just type in, I think it's like how to read a soil test report, Nova Scotia, and they have like a 3 or 4 page document that kind of outlines, similar to some of the things we talked about today, but a little bit more brief. And they have some tables, and I believe they have it for forages, grains, small fruits, tree fruits, and pasture maybe, but there's the 5 different categories that they split it up into.
Okay, yeah, I might connect with Amy and kind of see where they got those numbers, and if kind of why they differ from some other recommendations. So see.
Yeah, and the biggest difference I saw, as I said, was in the calcium and magnesium. The phosphorus and potassium were fairly similar, but yeah, and some of these numbers, you know, if you want to make sure that you know kind of the nutrient ranges, because if you get a measurement that is, you know, like 384 for available phosphorus and it says high, but it may not be as big of a concern yet compared to if you have something that's closer to 600, right? So it's important to kind of know the nutrient ranges rather than just looking at the ratings.
That's true. Yeah, good point. Does anyone else have any questions out there? You can post them in the chat or the Q&A, or you can text me too. That's fine. Yeah, we covered a lot of ground today. And like I said, this is recorded, so I'll share the link afterwards as well if you guys want to go back and take a look.
Yeah, and if you have any other questions, feel free to reach out to me personally. I don't have my personal information up here yet, but it's on the website, and Michelle has it as well.
For sure. Great. Just waiting a few seconds here just in case people are typing. Oh, I did get another one by text here. If applying lime in the spring, when you also want to apply spring fertility, will one application impact the effectiveness of the other? Do you know?
Oh, that's a good question. I guess it would depend on what you were applying. Just on the surface application, yeah, so the biggest thing is with the liming, and oftentimes liming is applied in the fall because it gives time for the lime to go to interact with the soil and change the pH. So if you were to apply them at the same time, you're not really going to see a difference in pH, and that pH is what's going to affect your nutrient availability. So I'm not sure if there would be any direct effect at the same time, but the biggest concern is that antagonism between calcium and magnesium and then potassium. I'm not sure if that, I'll dig into that a little bit deeper, but usually if you want your lime is going to take, especially if it's surface applied, then it's going to take a little bit longer for it to interact, so it may not interact right away, but you're not going to get that pH increase that's going to affect your nutrient availability from your fertilizers, if that makes sense.
Yep, sounds good. We have a few more questions. What happens if organic matter is very high?
So particularly I think with grapes and with apples. So with organic matter being really high, some that can affect your water holding capacity, but it can also, it does increase your nutrient uptake, but it may promote more like shoot growth. So it may allocate some nutrients to not necessarily the apple, but different parts of your tree that maybe you don't want to allocate nutrients to. But that was something I was going to look into a little bit more, because I see most of the resources say that for apple production, tree fruit production, you don't want extremely high organic matter. But whereas a lot of other production operations, you would want something a little bit higher.
Okay, interesting. And what about molybdenum on soil tests? Is deficiency not a concern in Nova Scotia?
Yeah, I was just looking at that. Molybdenum, yeah. So let me look into that one a little bit more. I don't want to speak too much about molybdenum before I look, because I'm not off the top of my head. I'm not with all the different micronutrients sometimes. But let me get back to you. I think that's Glenn on molybdenum in Nova Scotia, just to make sure that I am giving you the proper information.
Mm-hmm. Yeah, and like sulfur, I think can sometimes be an issue, and that's not available in the regular soil test, I think. That would be on like the additional package, I think.
Yeah, so sulfur is available. I didn't talk about sulfur too much today. And so sulfur used to be not as much of a concern because there was such a abundance of sulfur being deposited. But now, since sulfur isn't as readily deposited from the atmosphere anymore, that is another element that you may want to look at for nutrient deficiencies. But some of these nutrient deficiencies, as I said, are difficult to tell from the soil sometimes. So for some of the micronutrients or sulfur, you may want to look at tissue tests as well, just to see what's actually being taken up by the plant.
Yeah, absolutely. Okay, well, we're under an hour, which is great because I know everybody's been going to a lot of different webinars, and this is a lot of information to take in. So thank you very much, Caitlin, for joining us today and giving us a talk for tree fruit.
Yeah, thank you guys for coming.
So bye, everyone.